The liver, the silent organ. What has man's conception of this organ been, and how have we maintained its function? Thanks to the development of various diagnostic tools, we can now observe the liver as it is in the body without any invasive procedures. This is a computer tomogram of a normal liver. By superimposing cross-sectional images taken by X-ray, we can present a three-dimensional image of the liver. Because the liver is located almost at the center of the body and is this large, even in ancient times, no one doubted its importance. In Greek mythology, Prometheus steals fire from heaven and is punished by having his liver eaten by an eagle. What does the liver symbolize here? History tells us that as far back as the Babylonian age, the word for liver carried the meaning of life. This bronze model of the liver dates back to the 3rd century BC. It was excavated from the ruins of Etruria. The names of the 47 gods of disease are carved on the model. Hippocrates, the father of modern medicine, is credited as the first to scientifically see health and disease as natural phenomena. In his day, everything was explained in terms of the 4 basic elements: air, earth, fire, and water. The nature of things was determined by the interrelationship of these 4 elements. Hippocrates described the 4 humors, or fluids of the body, as blood, mucus, yellow bile, and black bile. He believed that disease resulted when there was an imbalance of the humors. His concept was that disease was not associated with any specific organ, but rather with the humors of the body as a whole. This is a laparoscopic image of the liver. In Hippocrates' terms, liver diseases can be described as a disturbance of the humors, such as the yellow and black bile. To restore the balance, he suggested mainly rest and sleep. This was apparently the best therapy for liver diseases in Hippocrates' days. "500 years after Hippocrates, by the time of Galen, a greater importance was attached to the liver based on the accumulated medical knowledge of those days. Galen thought blood was produced in the liver, which traveled back and forth through the veins. According to his theory, the building blocks of blood were nutrients absorbed by the intestines, and the sanguine quality was provided in the liver. Blood flows into the right side of the heart, passes to the lungs where it is cleared, and then returns to the right side of the heart. Part of the blood flows to the left ventricle through small openings in the septum. The lungs inhale vitality from the atmosphere, which reaches the left ventricle and is converted from the natural state into the vitality of life. It further travels to the brain, where it is converted into animal vitality and is distributed through the entire body via the nerve network. As you can see, Galen put the start of vascular in the liver. It was William Harvey who scientifically proved the circulation of the blood. After leaving the heart, blood travels through the arteries and veins before returning to the heart. After this discovery, he claimed that the intestinal nutrients enter the systemic circulation directly through the blood vessels and the lymphatic vessels. This approach greatly underrated the role of the liver. It was Claude Bernard who restored proper esteem to the liver. Doctrines on circulation up to that time emphasized only the oxygen supply. Bernard, however, discovered that one important role of the liver was to maintain the correct level of sugar in the blood. It is this hepatic function which keeps the intersomatic environment at a constant level. Here, the role of the liver as a chemical processing plant was newly recognized and drew increasing attention from later scientists. The gamma camera now enables us to see the systemic circulation which had greatly stimulated the imagination of our predecessors. Blood flows from the superior vena cava to the right ventricle, lungs, left ventricle, aorta, and to the liver. A systemic angiography naturally shows a high density of blood in the heart, but there is also a considerable accumulation in the liver, as can be seen from the fact that 20 to 30% of the total amount of blood is pooled in the liver at rest. One of the functions of the liver is the control of circulation. How did the ancient Chinese interpret the liver? The Chinese hieroglyphics for the liver is a combination of the body and a thick trunk. The significance being that the liver is the trunk of the body from where arms and legs branch out. In Chinese philosophy, the liver has a specific place in the 5 natural elements governed by the law of yin and yang, the cosmic dual forces. There were 3 gods, Fuyi, Shengnong, and Huangte, who preached the principle of yin and yang with the 5 natural elements. They systematized the medical field in China. There are dual forces, positive and negative, in the universe, and all beings come to exist as a result of the matching of these forces. The flow, change, and cycle of all things in nature are brought about by the interreactions of the 5 elements: wood, earth, fire, metal, and water. The principle of 5 natural elements obviously applies to the human body too, and the liver is counted as one of the 5 viscera components. These 5 viscera components have their counterparts in the 5 or 6 entrails to establish the relationship of yin and yang. Among the functions of the 5 viscera components, the liver is responsible for strategically protecting the body from invasions, governing the nerves and tendons and string blood. The Japanese word for vital is written with the characters for liver and kidney, and the word inseparable is expressed with the characters meaning liver and gallbladder. They are often used to denote a close and dependent relationship. If the liver is in charge of strategy, the gallbladder is the decision maker. They compose the 2 sides of a coin, which determines human behavior. These are ultrasonic tomograms of the liver and the gallbladder. Irrespective of the major functions of the liver and gallbladder in governing the mental activities as described in the principle of the 5 natural elements, there is little doubt that there is a close relationship between the gallbladder and the liver. Bear's gallbladder has been highly valued in folk medicine and is also one of the ingredients used in Chinese herb medicine. People probably believed in its efficacy because of the extreme difficulty in obtaining bear's gallbladder. Modern interpretation would refer to the efficacy of the bile acid that people appreciated. Medicine was brought to Japan along with other things from China. The Japanese not only learned the doctrine of the 5 natural elements with cosmic dual forces, but also factual human anatomy. At the same time, practical therapeutic methods utilizing herb medicine, acupuncture, and moxibustion were developed. This is a writing on healthcare published for the general public toward the end of the Edo period. Diet in Health, which is paired with sexual intercourse in health, has a pictorial representation of the viscera and describes the liver, saying, "All food and fluids must be well digested in the liver. Their essence nourishes the 5 viscera and 6 entrails. The digested substances are quickly transported to the spleen and serve as the nutrient of the body. Those who consume food and alcohol in excess of the liver's capacity will leave no time for the liver to digest the food and drink. The food will destroy the viscera and entrails, and that will eventually lead to various diseases." There is no doubt that excessive consumption of alcohol over an extended period of time causes liver damage. The liver is an extremely resistant organ, but an invasion beyond its ability to resist transforms a naturally beautiful organ into a tragic state. Genpaku Sugita and his co-workers opened the age of modern Western medicine in Japan. Their translation of Tahir Anatomia, which they undertook without a single dictionary, was possible only because of their enthusiasm to liberate man from the miseries of disease. But they assumed to have had a misconception of the portal vein of the liver. They described the function of the portal vein as the one which brings the blood in and out, acting like an entrance gate. The portal vein is in fact a vessel unique to the liver. The portal vein carries nutrients absorbed by the intestines to the liver. The lymphatic vessel transports fat. Fat heads for the liver, taking a detour. "75% of the incoming blood to the liver comes from the portal vein. The remaining 25% from the hepatic artery. 3 vessels travel in the liver: the portal vein, hepatic artery, and hepatic vein, and they present a complex network. This is an ultrasonic tomogram of the liver. The image moves from the inferior aspect of the liver to the superior aspect along the portal vein. This is a plastic mold model of the vessels. We can say that the numerous branches of the vessels make up this shape of the liver. The large branches hidden under the smaller branches can be seen in this radiogram. By carefully tracing these branches, we can divide the entire liver into several parts or segments, defined by each large branch. Probably due to these divisions, the ancient drawing of the liver was shaped like a hanging maple leaf. Dividing the liver into segments does have an important implication in the treatment of liver diseases. There are, however, no specific rules for this. This picture shows the 9 areas of the liver divided according to the course of the portal vein. These red vessels within the plastic model are the arteries. They coil around the portal vein but flow parallel to it. The branches of the hepatic vein in the liver and the hepatic artery. The portal vein. The branches of these three vessels interlock with one another. The portal and hepatic veins become progressively smaller as they continue to branch in the liver. Hepatic lobules are located at the 12th branch. These hepatic lobules are the basic functional units of the liver. There are about 500,000 hepatic lobules in the liver. Each hepatic lobule consists of 500,000 cells. A hepatic lobule is a cluster of cells in the size range of 1 cubic millimeter. The branches of the smallest portal and hepatic arteries that run along the hepatic lobule. The bundle of blood vessels with bile duct and lymphatic vessels. The blood from the portal vein and the hepatic artery flow into the central vein via the capillaries. These capillaries run in three-dimensional networks, and since they look like a sinus, they are called sinusoid. This is the sinusoid under a scanning electron microscope. It resembles a tunnel made by an alignment of cells. The sinusoid has a thin wall. The wall is like a duct, loosely connecting the endothelial cells and the Kupffer cells. The blood running in this duct escapes from the sinusoid wall and flows slowly, making direct contact with the hepatic cells. This is an ideal structure for the transport of substances between the hepatic cells and the blood. Thus, the hepatic cells and the sinusoid come in contact with various substances carried by the blood. A large amount of glucose is approaching. The hepatic cells immediately absorb the glucose. Through repeated steps of enzyme actions, glucose is converted into glycogen and stored in the cells. This is what takes place immediately after our meals. When we are hungry, our blood sugar level is lowered, and this is detected by the alpha cells in the pancreas, from where glucagon is secreted. Glucagon bonds to the receptors of the cytoplasmic membrane and transmits specific commands to the hepatic cells. Upon receiving these orders, androlyte cyclase, which is localized in the cytoplasmic membrane, is activated, and the production of cyclic AMP is increased. This, in turn, activates the next enzyme, and several other enzymes are activated consecutively. Finally, glycogen is decomposed to form glucose, which is then released into the blood. This is how the blood sugar level is maintained. The hepatic cells metabolize lipid and protein in a manner similar to this glycometabolism. These metabolites are transported by the sinusoid network. When the sinusoid network is erased out, we will see hepatic cells that are connected to look like winding walls. We'll see the narrow grooves running between the cells. These grooves are bile canaliculi and are involved in the hepatic function of detoxification and excretion. These are hepatic cells under a scanning electron microscope. The tunnel-like sinusoid can be observed where the hepatic cells are disconnected. Narrow groove lined with villi, that is bile canaliculi, course around the cells. Detoxification and excretion are some of the major routine functions of the liver. Bilirubin, for instance, is produced from the disintegrating aged erythrocytes and is brought with albumin when transported to the liver. Albumin is filtered out when the substances pass through the cytoplasmic membrane. Bilirubin in the hepatic cells is subjected to gluconic acid conjugation, and the final product is excreted into the bile canaliculi in a non-toxic form. Bile, which is secreted from the hepatic cells, flows from the bile canaliculi to the bile duct, as opposed to the direction of the bloodstream, which heads to the central vein. Where cultured hepatic cells are thinly spaced, 10 to 20 clustered cells form a number of blocks and grooves, similar in shape to the bile canaliculi. The cells that are busily moving around are the Cooper's cells. The substance secreted by the hepatic cells gradually accumulates in the bile canaliculi-like grooves, which look as if they're flushed out periodically. We now know that bile is not simply a waste product. Bile acid, which is the major constituent of bile, helps lipid digestion in the intestines. It's reabsorbed from the intestinal duct and returned to the liver. This circulation plays an important role in controlling the cholesterol metabolism of the entire body. Here we see two cells very closely situated with the secreted material stored between them. Probably a structure similar to the bile canaliculi is present at the site. One side of a hepatic cell faces the sinusoid, where the transport of materials takes place with blood. And bile canaliculi is on the other side of the cell to carry away the secreted bile. There is no confusion as to what is received where and what is to be sent where. The hepatic cells carry out these multiple functions very efficiently with the help of over 1,000 different kinds of enzymes. The liver is capable of performing its all-powerful functions only because of the outstanding ability of the hepatic cells. It is the first organ that is prepared to accept and process anything that is absorbed into the body. The liver, therefore, is subject to attack from many enemies. This liver succumbed to viral infection. This is destroyed liver tissue due to viral invasion. These black dots, seen under an electron microscope, are the virus invading the cells. Modern medicine, however, has succeeded in revealing the identity of the invaders. Future therapy, therefore, will primarily be directed against these enemies. We feel the movements of many parts of our body when we move. We cannot, however, feel the movement of the liver. The liver keeps its silence despite its vigorous working as our body's chemical factory. Even when under attack by enemies, the liver must perform its major function of maintaining internal balance of the body without complaining of pain. This is a gamma camera projection of our liver. Contemporary society is full of factors which affect the liver. While science and knowledge of the liver gradually advances, the battle against its enemies continues.